In the last video, we talked about this left-hand side of the matter chart. Now we're going to look at the right-hand side, mixtures. What are mixtures and how do we separate them? So a mixture is something that has a variable composition and you could separate physically. It's made up of two or more substances. We mentioned in the last video substances are elements and compounds. So it could be two elements, it could be two compounds, it could be an element and compound, it could be multiple compounds, but it's just a physical combination of one of those. So here are some examples. Brass is copper and zinc in a solid solution. You have sugar and water, like when you make iced tea. Sugar is a compound, water is a compound. They're two different compounds that we're mixing together. So that would also be an example of a mixture. Homogeneous mixtures are called solutions in chemistry, and they're when the sample is uniform throughout. So it basically looks like one phase. Like when you buy, let's say, Arizona iced tea, it's sugar dissolved in water, but it looks uniform throughout. Whether you get the top part of the iced tea or the middle part, it's pretty much the same consistency or uniform throughout. So in chemistry, if we had to describe the particles, we would say the particles are evenly spread out, or they're arranged the same. The prefix homo means the same, so in a homogeneous solution, the particles are arranged evenly or the same throughout the solution. A solution in which we're trying to get something to dissolve in water, like iced tea, we use this AQ symbol at the end of the name, and that just means that it's an aqueous solution. Anytime you see aqueous, it represents a homogeneous solution. So if something is able to dissolve or is soluble, we're going to say that it's going to be a homogeneous mixture. That means that the particles will all dissolve into the water and will be arranged uniformly throughout the mixture. So that's a key word. Whenever you see dissolved, we know it's going to be a homogeneous mixture. Heterogeneous mixture are when you have two different layers or two or more different phases present. For example, oil and water or sand and water. If you were to put sand and water in a beaker, you would see a layer of sand on the bottom and a layer of water. There's clear layers. All the sand does not dissolve in the water. It's not uniformly mixed. So heterogeneous, it's not the same throughout. There's, for example, sand on the bottom and water on the top. Or you would see two distinct layers. So if something does not dissolve, meaning something's floating, for example, that would be a heterogeneous mixture. Next, we want to talk about how you separate mixtures. Mixtures are separated physically. So I physically can, with my hands, perform a technique in the lab that will enable me to separate them. So for example, a very basic level would be something like salad. If I want to separate the salad into the lettuce and tomato and cucumbers, I could physically remove them and separate them. Compounds, remember we talked about last video, are only separated chemically. So you have to do a chemical reaction to separate them. All the methods we're going to talk about in this video are physical methods. That means you're separating them physically, not via chemical reactions. The first method is called filtration. Basically what you do is you take a filter and you put it into an iron ring and you pour your solution over into the funnel here. Funnel is, you're putting the paper in the funnel, I should have said. In the iron ring, you pour your solution into this filter paper and you put a beaker on the bottom. When you pour your liquid in here, so let's say you were to take sand and water and dump it in here. Well, the water would all go through the filter. That would end up here, down here. The sand would all stay on top. So filtration is a way to separate a heterogeneous mixture. Things that have two different phases, like a solid and a liquid. The solid stays up here, it can't go through the filter paper, but the liquid goes through. Now, let's say you were to take a homogeneous mixture, like let's say Gatorade. Gatorade has lots of sugars and salts dissolved into the Gatorade. If I take the Gatorade and I pour it through the filter paper, what happens? Everything goes through. So for homogeneous mixtures, we wouldn't use filtration. Filtration is only going to be used when we have two different layers or two different substances that are not soluble or not able to dissolve in each other. Heterogeneous mixtures. So filtration for heterogeneous. Okay. What about if you just want to separate salt and water? Well, then you could just evaporate it. We're pretty much all familiar with that, where you just take the sample of salt that's dissolved in the water and you just heat it up. When you heat it up, the water will evaporate and you'd be left with the salt in the dish. So that's another method, evaporation. Another method that you probably never heard of before is called distillation. And distillation is a process where you want to separate two liquids as long as they have different boiling points. This is actually how we separate the components of crude oil to get gas, by the way. So here on a basic level, we have a flask. And in this flask, I have two different liquids. Let's say we have alcohol and we have water. We're going to heat them up down here. Got a Bunsen burner. And when it reaches its boiling point, it's going to boil, means it becomes a gas. It goes through this condensing tube. Condense means it goes from a gas back to a liquid, and then we collect it over here and distill it. So if we have two different liquids here, one boils at 50. When it hits its boiling point, the alcohol will rise, and I can collect it. The water is still sitting over here. So now I have alcohol in this right-hand flask, and over here the water's still sitting here heating up. Maybe it's getting to like 70 degrees Celsius. It still hasn't reached its boiling point, so it's staying as a liquid. So it's a way to separate two liquids that have different boiling points. If they have the same boiling point, this won't work. And remember, the boiling point is a physical property. So I'm separating two liquids based on the physical property boiling point. Another method is called chromatography. I know you probably have done this with plant pigments in biology. But what we're doing with chromatography is, let's say you take an ink, like a little marker, and I put it on this chromatography paper here. What happens when we put it in a solvent like water is eventually the pigment will rise. And the amount that it rises varies depending on what is that made up of. So in the case of ink, it's going to travel, and there's different components within the ink. Maybe you'll see some red, maybe we'll see some purples in here. But the idea is that it rises depending on its attraction with the paper itself, something that we'll talk about later in the year called polarity. It also has to do with its solubility. Last thing we want to talk about in this video are some things that are not matter. So that concludes our discussion of ways to separate mixtures. We want to talk about, what is energy? Energy is the ability to do work or transfer heat. It is not matter itself, though. So there are different types of energy, like potential and kinetic. Heat is actually a form of energy. There's chemical energy, electrical energy. Some of the words that we're going to use to describe energy are exothermic and endothermic. Exo, think about an exoskeleton, is a process that is going to release heat. So for example, when you sweat, you release heat from your body. Any process that's going from a gas to a liquid, or a liquid to solid, or a gas right to a solid, these are exothermic processes. We'll talk about that more as the year goes on, but it's a process of releasing heat. From a gas, I release heat to become a liquid, or liquid, you release heat to become a solid. The opposite process is called endothermic. It's a process that absorbs heat. So for example, if you go from a liquid to a gas, you have to take in heat to make the water boil, for example, or a solid. You have to absorb heat to make it melt. We need to know that temperature is not energy. We're going to talk about this more as the year goes on, but just so that you start to get an idea, temperature is actually just a measure of the average kinetic energy of the particles. So how fast are those particles moving? That's going to be what your temperature reading is. You can convert from one form of energy to another, like a roller coaster, potential to kinetic. We could transfer from mechanical energy and motion to electrical energy. And this entire year, we're going to be talking about different energy transformations. We just need to remember that energy can't be created or destroyed, but we can convert it from one form to another. Same thing with mass. You can't create or destroy matter. So the mass of our reactants will always be equal to the mass of our products. And we'll look at that as the year goes on as well. These are some vocab words that you should have an understanding of now that we're concluding our unit on matter. So you might want to take a look at these on the PowerPoint. And there's also exam review for you.